Alrighty guys, so in this lecture we're going to continue with our solution stoichiometry lesson, but this time we're going to be looking for the mass of all the products, not just one of them, just like we did with regular stoich. So let's start off with step one. Step one, we want to start off by balancing this equation. So if we want to balance the equation, we want to start off by counting all of the elements on both sides of the chemical equation. So let's just start by listing the elements that we have. We have calcium, sulfur, and oxygen. Okay, so let's count how many of each we have on the left and on the right side. So if you take a look on the left side, we have one calcium, we have two sulfurs, and three oxygens. And then for the right side, we have one calcium, we have two sulfurs, and we have two oxygens. Okay, so it looks like the oxygens are the ones that are not balanced. So what we're going to want to do is we're going to have to add to the side that has fewer. So we have fewer oxygens on the right side, the product side. So I'm going to add another oxygen, but I can't just add one of them. I have to add the whole molecule. So I'm going to add O2. If I add an O2, I've added two more oxygens, so I have four on the product side, which means I have too many on the right side, so I have to add some on the left side. Unfortunately, I can't just add one. I have to add the entire molecule, so I'm going to add CaS2O3, the entire thing, which will change all of my numbers on the reactant side. So on the reactant side, I have two calciums now, and I have four sulfurs, and I have six oxygens. Okay, so we've messed up everything now. Nothing is balanced, but let's finish up the oxygens first because we're almost done. Since there's fewer oxygens on the product side, the right side, I'm going to add another O2, which means I have 2, 4, 6 oxygens, which means they're balanced. And then for the calcium and the sulfurs, if I just add CaS2, that means on the product side, the right side, I'm going to have 2 calciums and I'm going to have 4 sulfurs. And so everybody is balanced out and everybody is good to go. So I just need to write my coefficients or the numbers in the front. I have 2 of this big molecule, so I'm going to put a 2 in the front. I have 2 CaS2, and I have 1, 2, 3 O2, so I'm going to put a 3 in the front. Okay, so that's step one. Step one is just balancing. It's basically just what we've been doing for a long time now. Now what we're going to do is step two is we're going to figure out what is our given and what is our end. And so let's read the problem. So in the problem, it's asking us, suppose that 900 milliliters of a 1.8 molarity CaS2O3 solution decomposes. Okay, so we have all this information about this compound right here, CaS2O3, which means this is going to be our given. Okay, our given is going to be this information right here. And since we're talking about molarity, that means we're going to be using the molarity formula. So capital M equals moles over liters. Okay, and the question is asking us how many grams of each product will be produced. So if you take a look at this equation, we have two products, right? Products are the stuff on the right side. So these are our products. So we're going to be looking for both of them. So we're going to be looking for grams of CaS2 and we're going to be looking for grams of O2. So we're going to have to do two different stoichiometry problems in order to solve this problem. All right, so we found our given and our end. So what we're going to do now is step 3. We're going to find the moles using the molarity. Okay, we said earlier we're going to be using the molarity formula. So capital M equals moles over liters. Okay, so let's plug in the numbers that we have. So for molarity, we have 1.8 capital M. So I'm going to just put 1.8 molarity equals, I don't have moles, which is what I'm going to be looking for, but I do have liters. Because if I have 900 milliliters, I can convert that using dimensional analysis. So 900 milliliters, we're going to set up a fraction. We're going to put milliliters on the bottom, and we want liters, so we're going to put liters on the top. Now, if you guys remember from previous assignments, we know that 1 liter is 1,000 milliliters. So we're just going to plug this equation in here. I'm going to put 1 liter on the top and 1,000 milliliters on the bottom. The milliliters will cancel out. So I just do 900 divided by 1,000, top divided by bottom, or multiply tops divided by the bottom, and that is going to give you 0.9 liters. So that's what we'll plug in for liters right here. So I'm going to plug in 0.9 liters. Okay? Alright, so we have our liters. Now we can just solve for moles. Easiest way to do this is just multiply both sides by 0.9, because if you do that, you'll cancel out the bottom. And so what we're going to get is, for our moles, we're going to have to do 1.8 molarity times 0.9 liters. Okay, and so if you plug that into your calculator, you'll get 1.8 times 0.9, and that'll give you 1.62, which means that we have 1.62 moles of what compound? CaS2O3. Okay, so we have the moles now, and now we can move on to step 4. Step 4 is where we do stoichiometry or dimensional analysis to find our endpoint, our end, so the mass of both products. Now, since we have two products, we're going to have to do stoichiometry 2 different times. Okay, so for the dimensional analysis, remember, since we already have moles, right? In regular stoichiometry, we start with grams and then we do g-mg. But here, since we start with moles, we are going to do just mmg. Okay, moles, grams. All right, so let's start off by finding the first one, CaS2. So the first time we do dimensional analysis, what we're going to do is we're going to start with the number that we got right here, 1.62 moles of CaS2O3. So I'm going to start with 1.62 moles of CaS2O3. Okay, and since we're doing mmg, we have m already, the first m, and then we need to do two more fractions because we're doing m, and then the second m, moles, and then we're going to set up our final fraction, which is going to be g, which is grams. Okay, so that's why it's mmg, because it's moles, grams, mmg. All right, so we know that our last two fractions are going to be about whatever we're looking for. So we're in this problem, we're looking for CaS2, so that means the last two fractions have to be about CaS2. So we're going to put moles of CaS2 and then grams of CaS2. That way, when we solve out the problem, we can find grams of CaS2. Okay, from here we can just start filling in the bottoms of the fractions. We know we want to get rid of moles of CaS2O3, so I'm going to put moles of CaS2O3. And so since I have moles and moles on the same fraction, we know that we're going to get the numbers from the chemical equation, the thing that we balanced. Okay, so if you look here, what number is next to CaS2O3? We have the number 2, so we're going to put a 2 on the bottom. What number is next to CaS2? It's a 2, so we're going to put a 2 on the top. And then that allows us to cancel out the moles of CaS2O3. And since I have a 2 on the top and a 2 on the bottom, the 2's can actually cancel out too, which means we don't have to do any math or calculations for this fraction. Lastly, we're going to try to get rid of the moles of CaS2, so I'm going to put moles of CaS2 on the bottom. Since I have grams and moles on the same fraction, I'm going to get the numbers from the molar mass. Okay, since we're getting numbers from the molar mass, we're going to have to add up the molar masses of Ca, calcium, and 2 sulfurs. Okay, so if you look on your periodic table, the molar mass of calcium, Ca, the number on the bottom, is going to be 40 grams per mole. For sulfur, it's going to be 32. But since there's 2 of them, right, there's 2 sulfurs, we're going to have to multiply that by 2. Okay, which will give us 64. So we're going to have to add 40 and 64 to get the molar mass of CaS2. So the molar mass of CaS2, 40 plus 64, is going to be 104 grams per mole. And so we're going to plug that in here. Our number on top is going to be 104 grams of CaS2 per every 1 mole of CaS2. And then these units will cancel out. And there you go, you can solve out that problem. So from here, it's pretty simple. You just multiply the tops, divide the bottom. We start with 1.62. We can skip this second fraction because everything got crossed out. And then we just need to multiply it by the top of the final fraction, so times 104, and that's going to give us a final answer of 168.48 grams of CaS2. So that's going to be our first answer, okay? Okay, so that's our first answer, but we're not done yet because we're not just looking for grams of CaS2. We're looking for grams of all or both products, each product. If you notice, like we said earlier, there are two products, and so we found this one. We're good to go with the first product, but now we have to find the molar mass or the grams of the other product, O2. So we have to do dimensional analysis again, but luckily for us, we have the same starting number, 1.62 moles of CaS2O3. We don't need to do this whole molarity thing again because we already found how many moles of CaS2O3 we have. So I'm just going to start by writing down the starting number again. So 1.62 moles of CaS2O3. And again, we're doing mumga, moles, moles, grams. So I'm going to set up a fraction. I'm going to do moles. And then our last fraction is going to be grams. But this time, instead of finding CaS2, we're looking for O2. So since I'm looking for O2, the last two fractions are going to be about O2. Alright, so I want to cancel this out, so I'm going to put moles of CaS2O3 on the bottom. Since I have moles and moles on the same fraction, we're going to go on the chemical equation to find our numbers. The number in front of CaS2O3 is still 2, so I'm going to put a 2 on the bottom. The number next to moles of O2 is 3, so I'm going to put a 3 on the top, and that's going to allow me to cancel these out. Okay? Now I have moles of O2, which I want to get rid of, so I'm going to put moles of O2 on the bottom. Since I have grams and moles on the same fraction, I'm going to get the numbers from molar mass. Okay, oxygen, O2 is made out of two oxygens, so if you take a look at your periodic table, oxygen is 16. Since there's two oxygens, it's going to be 16 times 2, which is going to be 32. So O2 has a molar mass of 32 grams per mole, which means I put a 32 on the top and 1 on the bottom, and then the moles of O2 can cancel out. Alright, so we canceled everything out. Now we just need to do the calculations by putting them into the calculator. So multiply the tops, divide the bottom. So we have 1.62, and then this first fraction, we need to multiply the top, so multiply it by 3. And then we divide by the bottom, which is 2, so we divide by 2. And then we multiply by the top, which is 32. And then we can skip the 1 because it'll be the same number. So our final answer here will be 77.76 grams of O2. And there we go. We have our final answer. Because we wanted to find each product, we found the molar mass of CaS2 and we found the molar mass of O2. Okay, so hopefully that was helpful. This will be how you solve out the stoichiometry for multiple products. If you guys have any questions, let me know, and we'll see you guys next time.